Alright, good afternoon everybody. This is Dimitri. He's going to talk to you about Aldebaran Robotics and open source.
Okay, so thanks for being here. So I'm Dimitri Merejkowsky, and I work at Aldebaran Robotics since 4.5 days. So we are the company building this robot. So we have a stand in AW, so don't hesitate to go to our stand and talk with us. We've got more robots doing more crazy stuff. So let's get started. So just a few words about my company. So it's started 6 years ago, and now we have more than 200 people working at Aldebaran, 50 just for the R&D. We have offices in Boston, in Shanghai, and in Paris, but all the R&D is done in Paris. We have more than 2,000 robots in the world, and it's used by something like 200 or 300 universities. So a few words about the robot. So actually, this is the picture of the first humanoid robot ever to be in the South Pole, and that's someone from. And so those are real penguins. So a few words about the robot. So in 2006, we only had a very basic prototype. And the second you see over there is the one we used to add the Robot Cup to be the next standard platform league. So the idea is that since the third prototype you see over there, the now robot is used by the Robot Cup for the standard platform. So this means that you have two teams, each one has 5 nows, and the nows are playing soccer together. And since 2008, we've improved the hardware. So now we've got a very robust robot. It can fall like 1,000 times over its own side, and it doesn't break. So that's where we are now. So a few words about the robots. So there are tons of captors. So there are 4 microphones, here, and there. So you can do a sound localization and know where people are, when people are talking, where they are, and look at them. He's got 2 cameras, one over here and one at the bottom. So I can see in front of him and can also see at his feet to avoid walking on obstacles and so on. Also, to avoid obstacles, he has two sets of ultrasons. He also has an inertial sensor, so when it does like this, he knows it. And also use it to know when he's falling, and he can protect himself and then get up. He also got lots of tactile sensors, so the head has tactile sensors, the hands also, some bumpers here and there, and some pressure sensor also here. And again, he uses it to stabilize his walking. He has 25 degrees of freedoms. You can control the motors one by one, or you can do very advanced stuff, like just set the robot, go to there. It's going to compute all the steps and do the walking and so on. So the robot comes also with a lot of tools. So we've got a big community of developers and users. We've got a developer program. I'll say more about this later. And we also have lots of tools to help you program the robot. So we have a graphical environment called Choreograph. And so you can just program the robot by dragging boxes and connecting them. And we also have SDK and a lot of various programming languages like C++, Python, Java, .NET, and so on. So this is an overview of the software that we wrote. So we do everything from the mechatronics and the low-level firmware code up to all the embedded software and the desktop software. So here you have a stack. So we've got the embedded software like the firmware and so on. On the head, so the head is the big, it's supposed to be on a head. And at the bottom, you've got a Linux, so it's based on Gentoo, so it's a real Linux. We give you a shared access and so on. Above the Linux, there is a daemon called HAL, which is used to control the hardware and so on. So it handles all the communication between the motors, the sensors, and so on. Above that, there is a layer called qiMessaging. So qiMessaging is just a core library that is used to make processes communicate together. Above qiMessaging, there is a lot of various modules. So we offer you a huge API, and it's split across various modules. So you've got a module for motion, a module for walking, a module for speaking, and so on. So the whole stack with the HAL, qiMessaging, and the module is called Naoki. So this is our main framework. And Naoki is able to run on the robot, but also on your desktop for simulation. So of course, when it runs on the desktop, there are a few things you don't have, like the hardware or proprietary third-party library like text-to-speech. But you've got the same API. And above Naoki, you've got lots of various applications. So for instance, there was one guy that wrote this application where the robot had an alarm clock. And when it rang, the robot walked away. And so you have to get up the bed and follow the robot and turn the alarm off. Yeah, one last thing. So the qiMessaging core library is also available on desktop, so Linux, Mac, Windows. And so that's how you can write code on your desktop that is going to communicate with the robot. And of course, we've got this SDK and the documentation available too. So one last thing, so Aldebaran Robotics does not only do this now robot. We also are involved in a European project called Romeo. So this big humanoid robot is 1.40 m. And this one is really going to be it's really supposed to be in the people's homes. So it has been designed to be able to do stuff like carry heavy stuff, open doors, walking stairs, and so on. Next to Romeo, we've got the Jazz robot. So Jazz is a robot that is designed to be a telepresence robot. So basically, you can be in your home and you have the robot walking around the office with a little camera on top. And so people can see you and talk to the robot, and you can see them from your house. So if someone here has seen The Big Bang Theory, there is an episode where Sheldon does exactly use this kind of tools. And so the fiction has become reality. That's a bit funny. So what do we do at Aldebaran, and why do we have these robots? So the main idea is that we want to bring robots to people's home and help mankind. So we want to have robots that really help people. So the big goal is to have this companion robot that is at home and is, I don't know, doing your dishes, watching elderly people, helping blind people, this kind of thing. So this is a really big goal. And to do that, we chose to start with a smaller one, but a robot that is designed so that it's easy to interact with him. That's why we have all these sensors and so on. And that's why we are building this huge community, both with a searcher for all the artificial intelligence we need, all the research we need in order to achieve this goal. And also, this is why we work with lots of developers like you to create the applications that are going to run on this robot on the future. So that's the main vision of Aldebaran. So of course, we are at Fosdem, so we are going to talk about open source. And I'm just going to take a little time to tell you two stories. So by the way, this was taken at Linux tag. So we do like going to this kind of conference with lots of developers and talk to them. I really think we've got lots of energy to share between the community of developers at Aldebaran and the other communities. So the first story is now in the Wi-Fi. So maybe some of you know WPA supplicant. So it's a really low-level tool, and in the first version of the robot, we had a very strange web page with some host scripts that were trying to configure WPA supplicant. It was a big mess. We couldn't do roaming and so on. It was very hard. And we had this Wi-Fi driver that was a bit buggy, and we were a bit stuck. And so that was three years ago. So what happened? What happened is that there was some really nice people working on the kernel, and so they patched the driver, and now we have a really nice driver that works very well. We've got also this community that is maintaining the wireless compat layer for us, and we use that. And we also have a guy at Aldebaran who is working actively on a project called connman. So connman is a bit like network manager, but for embedded systems. And if my desktop is able to be connected to the robot right now, you can see it's auto-linked. That's because of a contribution of Aldebaran to connman. So next up, we are going to talk about build system. I know there are lots of build system around here and lots of talks, so we've got our story too, because obviously that's something we have to do. We have to maintain a distribution for the robot. We have a SDK to have on 3 different platforms and so on. So that's really a big topic for us. So at the very beginning, we were using buildbot, so it was the first attempt we made. And the good part was that we had a very fine control about compilation, and it was easy to use, but there was not that much package at the time. It was in 2007. Yeah, so we stopped using buildbot, but we still have still have people at Aldebaran that are very enthusiastic about this project, and they are still contributing to buildbot. Next, we use openembedded. So openembedded is a real distribution. We liked it, but the thing with openembedded is that it's really targeted for cross-compilation. And actually, we don't really need cross-compilation because the robot has an Intel inside, x86. And so it was actually not that useful to use openembedded for that. And also, there are no support for binary packages, so we had to recompile everything every time we wanted to do an image. And yeah, just for the fun, some people consider putting Windows embedded on the Nao. They tried to develop a video driver for 3 months, and then they came back and say, no, it doesn't work. So since 2012, we switched to gentoo. And we are really happy with gentoo because it's a source distribution, so we can control how we compile, we can optimize stuff. It's really nice. It really has a nice community. The recipe we use are very close to what upstream does, which is always a good thing. And there is support for binary package, so we can really use that and avoid recompiling everything all the time. And yeah, so far so good. We are really happy. This is a picture of Nao just saying hello to the gentoo guys. Again at Linux Tag. This is something that came up really recently in the last release made by Aldebaran. So we've got this OpenNAO virtual machine. So the idea is that you get exactly the same environment as the robot, but it's running on your desktop, and you have all the compilation tools inside the VM. So you can just type image on the VM, and you've got your binary package, and you can just deploy it to the robot. So that's really nice. And one reason we did that is that we wanted to make sure it was easy to write application for the robot using third-party libraries. Say, for instance, you want to write an application for the robot that is doing QR code. There are lots of libraries for doing that already. So there's no point in people trying to recompile that all the time, and you can just use the gentoo work, do the binary package, and then sell it on the robot. And of course, if you take the total number of lines of code we have today at Aldebaran that we wrote ourselves, both for the embedded system and for the desktop tools, it's a total of 6 million lines of code, and there's something like 30,000 lines of CMake code. because CMake is cross-platform and we need that. And we wrote a very nice layer on top of that, which was qiBuild. So it's yet another build system for C++ and CMake. I know there are tons of them, but this one is better. So why is it better? So it's open source, of course. It supports cross-compilation. It supports Linux, Mac, Windows. It also supports Visual Studio. It also supports binary packages for the desktop too, something you seldom see. And it also supports making software that you can redistribute later, so you can just compile your software and put all the library together and give the pre-compiled stuff to other people to use. So it's all written in Python with the CMake layer on top. It's available on GitHub, so you can check it out if you want. And the last feature we added was qiBuild deploy, so you can just type this command, and it's going to cross-compile your source code, send it to the robot, and configure the remote debugging for you. So that's really nice. So I want to take the time, because I'm here for them, to just say a big thank you to the community. There are tons of great tools that are done by the open source communities, from CMake to Python, obviously. The guy from Qt Creator, I just went to see them yesterday to just say thanks. That's one of the good things at Fosdem, that you can just go to people and put a name in front of the software you use every day. That is really nice. And we also use lots of tools that the open source projects are using too, like Gerrit for the code review and Jenkins. So Jenkins does everything for us, from the automatic testing to the automatization of the deliveries and so on. And so what we want to achieve is to give back to the community a bit of what we've taken. So the big motto is created by us, improved by everybody, which is such a nice slogan for open source. So we are officially showing code since May 2011. We've got a GitHub webpage where you can see all the projects that we opened. So there are a few of them right now, but many more to come. qiBuild is released under a BSD license. And yeah, just check out our webpage on GitHub. Our account is just in Aldebaran. So next, I'm going to say a few words about what is going on in the future. So right now, the parts that are open source in the robot are the distribution. Of course, everything. Every time we use a GPL library, we give you access to the patch we've made, and also even the Git project. So there is for instance, there is our fork of the kernel on GitHub if you want to check it out. But right now, the core library, the communication library, is closed, and we want to open that. We want to open that for many reasons that you already know, like it's easier to support new platform because Aldebaran doesn't have to precompile it for everyone. It's easier to adapt it to other build systems. It's easier to adapt it to other framework. We know there are tons of open robotics framework in the wild, like ROS, for instance. And what we did with key messaging is to have this open library, open format, open wiring format, so that it's easy to tweak it or to plug it with other frameworks and so on. So I was talking about the developer program before. So what we have here is that we have a very nice environment for developers. So there is a form, so you can put your software here. You can share the source code with everyone. If you go to see our stand, you'll see many demonstrations. All the source code for this demonstration are here. There is also a store, so you can publish applications or sell applications and download them. And so how you get in is you fill a form to prove you are able to program, and then you buy a robot for 3,000 euros. So what you need to know is that the public price for the robot is 12,000 euros. In fact, by selling you at this price, we want you to create application for the robot. So if you heard about the now Dev Days, so that's something we do quite often. We invite all the members from the developer forum to come and see us at Aldebaran in Paris to just hack with us. So this is a picture from one of these events. And so there was something like 50 people just hacking on the robot all weekend, staying very late on the Saturday and so on. And there was a competition, and the goal was to write the best application possible. And here you are seeing a picture of that. So it was a physical coach. So the robot was doing push-ups on the ground, and then look at you and say, no, do the same. So the guy who won the prize had the opportunity to come work with us for 2 days. So he spent 2 days with the people from Aldebaran, the guys that wrote collabs, the guys that make the demo and so on, to improve his application, and it was such a nice experience. Yeah, a few stuff more. What's really nice with the developer program and Aldebaran is that it's really close. So we do some beta releases, for instance, and I remember one time we send a message to the forum saying the beta is available, and the next 2 hours we've got tons and tons of downloads, and people are already sending bug reports and so on. So that's really great. So if you join the developer forum, you can just ask someone, and you can be in touch with the guy that is responsible for this feature. It's really open and easy to share ideas and so on. We are also hiring. So Aldebaran is still working on very big projects, all these robots, all these huge goals to achieve. We've got lots of various topics, lots of job offers. So everything is on a website called Shape the World. So just shapetheworld.fr. You can see all the job description here. And don't worry, send your resume anyway, because sometimes we just get a resume and then we know we want to hire this guy and we find out a job description later. So don't worry. And yes, come and join us. We are a very happy company. We have a very young and enthusiastic team. So this is an example of our building. So we have this very nice terrace open in the air, so it's a great place to be in summer. So yeah. And again, one of our mottos, so this is work hard. So here you can see people working on the here. So it's they are working on the prototype for the Romeo. So it was the first prototype. Here you can see people fixing robots, and in the bottom it was during the Universal Exposition. So we have often big challenges to meet, and that's also really exciting. But we also know how to party, so there are a few photos. So here you've got a picture of Nao during Christmas. Here's the Nao Lebewurst. So it was so there was a RoboCup in Germany, and so we sent some people officially from Aldebaran for support and so on. And there was a few geeks inside the company that said, "Oh, we want to come too." And so they just took a bus and drink some beer and be in the audience and just making sure everyone was happy and having this really weird fake hair. And the guy you see here with the big smile and the big hair, who looks a bit like having a big time, is the CEO of Aldebaran Robotics. So that's the end for this talk. So I'm just going to show you a little demonstration. So what you are going to see is first time we have an open stack. So everything that is on my desktop is open source, and the only stuff that is closed in open source are really the implementation, like the test-to-speed that is proprietary, or really a few stuff, but all the core libraries and the communication format are open. So let me show that. Just to switch to a better profile. So here is what the source code looks like. So you create a session, and then you connect to the robot. So this one is called Pedro, so we've got a nice AVI functionality working out of the box. And then you create a service, and then you make it say something. So let's start with, just to prove I'm not making it up. Let's start with hello world because, oops, sorry. Let's start with hello world. So the example is in Python, but again, C++, Java, and so on.
Hello world.
Yeah. So now the god of the programmation are with us, so we can start seeing something else. So let's try. Oops. Let's try Fosdem because we are in Fosdem, and that would be a shame not to have that. Oops.
Hello Fosdem.
Yeah. Okay, so that was it for this talk. So we can just put my last slide, if I can do that. Yeah, so of tooling, so we've got a documentation available, so you can browse source code. So the example you are going to see are not using key messaging because key messaging is not finished yet, but soon. We've got the Aldebaran GitHub available, so you can see all the projects we have. Here's my email if you have any question. And again, there is this shapetheworld.fr website you can join to see our job offers and look around. So come and see us at the stand 6. Come and see me afterwards. We've got badges, we've got brochures, we've got everything. And yeah, if you have a question, I think I'm a bit in advance, we can take them. Yeah. Oh yeah, I didn't. So everyone uploads, so I did not. So I've got another example. So here we are using various services. So we've got a service called Motion. So you can see there is some really high-level stuff like wake up and rest. We've got the text-to-speech we've already seen, and we've got the behavior manager. So basically you can install behavior on the robot and just play them. So we can try to do that too. Let's do this.
Hello world.
Yeah. I won't make it work live on a table like that because nah, I'm taking enough risk already. But if you want to see the robot work, you can go to our stand. I've got this really nice, simple demonstration. So the robot has wave his hands. You can just took him by hand, and he follows you. So that's a really nice way to see him work.
Look to your left. Here I am.
Yeah.
You said in the beginning something about 25 degrees of freedom.
Yeah.
Do they have any other purpose than waving hands or some impressive stuff like that? I mean, are they for some functionality or are they just some kind of public relation?
I'm not sure I'm following, but the question was what the robot can do apart from moving?
I mean, 25 degrees of freedom sound spectacular. I even think, well, I agree that it's quite a task to coordinate them, but do you really need that many degrees of freedom to perform the task you are wanting to do with your robot?
Yeah, I see your point. So the question is, why do we have so many degrees of freedom? So the answer is that because we wanted a humanoid robot. So we wanted the head, we wanted it to be able to sit down and to walk and so on. It was really important for us to have this humanoid robot for two reasons. First, the fact that he looks like this and is a bit like a child and so on makes it very easy to interact with him. And also the fact that we want to have robots in the people's home in the future. We need to have humanoid robot because your home is designed for humans. If you think about stuff like taking off the garbage or opening a door and so on, you have to be like a humanoid robot to do that. So that's why we choose to have all this complexity, and that's why we work to make the walk this way, or all this high level and complex way of making the robot move.
Okay, we have another question.
Hi. How long the battery last? I mean, what's the autonomy of the robot average?
Yeah, so the batteries, the life of the battery is 2 or 3 hours, depending on what you are doing with the robot, obviously. Mm-hmm. And yeah, that's it.
And has it a cradle so the robot can go by himself to the recharge area or something like that?
There is a project like this, so it's called the Now Energy Station. Mm-hmm. So the idea is that you have a pod, and the robot can just walk backward, and there is a magnet, and so it connects to the magnet, so it can just move around freely because there is a little cord, and then when it wants to get out, it just do that. Oops, click, click. And then it can just get away and continue. So we did, Aldebaran did the hardware part, the mechanical design and so on, because that's what we are good at. And then we started working on all the navigation problems and so on, and we just give the hardware to people from the developer program and said to them, okay, just make it happen, make the navigation system work, make the robot realize the battery is empty, and just go back to the next station and so on. So that's what I was saying earlier. We've got this huge goal, which is having robots in people's home. And so Aldebaran is doing the part of the industrialization, the hardware, selling it, doing the support and so on. And we work with people like you, like developers, to help with us and create with us. Yeah.
Yes, so I understand that you mechanically have 25 degrees of freedom. Yeah. I kind of understand that you have an application processor and a real-time part to control it, right?
Yeah.
So my question is, how many degrees of freedom are you able to control at each time? I think it's not 25, right?
Yeah, actually, yes. So what's happening is that at the core of in the torso, there is a ARM processor. So there is no operating system on it. And its only job is to take all the inputs from every sensors and send it back to Naoki so that we can do some high-level control loop and so on. And then receive the command and send it back to the motors. So this is really simple. It does always the same thing every time. So we can keep the real-time loop at a rate that is 10 milliseconds. And then we have a much lower and more precise loop inside the motors. It's on FPIC, and here you've got some millisecond feedback. So that's how we do it.
Thanks.
Yeah?
That real-time motor controller, the software that's running, is that open source, or at least is it technically possible to replace it?
You mean the part that controls the hardware, or the part just above?
The low-level motor control, yes.
So the firmware is closed mostly for security reasons because we don't want you to burn the motors or things like that. But I was talking about the feedback loop from the HAL. And actually, you can plug it. You can plug yourself here if you want. So we've got people doing that. So 10 milliseconds is enough if you want to try to redo your own work, for instance. And we've got people doing it. Yeah, and just to elaborate a little bit about your question. So I mentioned earlier that we want to open our SDK. So I'm not sure yet what is going to be open, what is going to be closed. I know the core library for communication is going to be open. And I think what I would like to happen is to have an open API, which is cross-robot. And so we could have a proprietary Aldebaran implementation and then open implementation. And I think that would be the best way to do it.
I think that someone should ask this question.
Yeah.
Does it have the 3 laws?
Sorry?
Does it have the 3 laws?
Oh, yeah. How can I answer that? So the answer is no, but obviously, yes, what's really interesting with this kind of robot is that you start seeing stuff that was really in fiction happening in reality. And that's really nice about working in Aldebaran, is that you can be at the place where things are changing. So we've got people thinking really hard about what is going to happen with this kind of tool and what are the consequences of having a robot interacting with human and so on. There's several possible answers to that. One thing I know is that when I start working on that, I was in a mood like, okay, doing robot is fun and I just want to have fun. But there's more to that. And in Aldebaran Robotics, something like 2 or 3 years ago, there were people using the robot to help autistic children because the problem with autistic children is that they have trouble interpreting what people are feeling and reading their feelings. And the nice thing about this robot is that it looks human and can express emotion in a very simple way. And so it was much easier for the autistic children to interact with the robot. And what happened is that once the autistic children was out of his own closed world, thanks to the robot, we've got some doctors who could help him out. So we are really helping people to be better, and that's something I was not expecting at all. Yeah.
So does the robot have adaptive trajectory planning coupled to video recognition? Say, for instance, it has to pick up a moving part.
Yeah, so you have the basic block to do that because you've got some visual recognition. You can analyze the video stream for the robot and so on. So the strategy with Aldebaran is that we give you the basic blocks, but also now we started adding more stuff. Like for instance, in the Watt.12 version, you've got nothing like that. In Watt.14, you've got a C++ module that is using the camera to make sure the robot works straight. And so this is happening, actually. So it's, I know it's some subjects people want to look for and research and do themselves. And we also know that people need something that works out of the box. So we do a bit both.
Excuse me. My question is that here, does your control system have this capability of walking on rough surfaces?
So the work of the robot, so it works on very different kind of floors, like for instance wood or carpet or things like that, and can switch from carpet to wood without falling. Because we've got a closed loop like this, so it can also walk on his own cord, things like that. But obviously, if you start having some big slopes, or yeah, you can make the robot fall. But again, the idea is that the robot is robust enough to just get up when it falls, so it's not that hard. Not that a problem.
Here, on your right.
Yeah.
Are you competing or planning to compete in a RoboCup competition? One of the
So what we do at Aldebaran is that we sell the robot for the RoboCup teams. So we don't. It would not be very fair if we were playing too. So the answer is no. But as I said earlier, we follow the RoboCup, and when it's close to where we are, we just go there to enjoy and just party with the competition and so on.
How many teams are using your robots for the competition?
I don't really recall right now, but I don't know. Maybe I really don't know.
Thank you.
I have a question here on your left. So for your robot, is there any specific safety regulatory rules you have to follow? And if so, how do you expect the software you developed, even the third-party software, to follow such rules? Thank you.
So the question was, is there rules when you want to write software for the robot? Is that the... Sorry.
So the question is that, do you need to pass some safety regulatory rules before your robot can be sold? And if that is true, you have to pass some safety regulatory rules. How do you impose such rules in your software? Especially the software that is, you just showed, demoed, the Python code, which can be written by someone else, like people here.
Yeah, that's a big subject. We don't really have the answer yet. So right now we just keep everything open, so we even have root access to the robot actually. We know it's a big topic because obviously you can't afford that if you have a robot on people's home, because what's new with this robot is that you have lots of privacy issues, and so it's still a work in progress actually. I don't have any good answer for that. We want to have something a bit like we're in a mix, a bit like between Apple and Android, where in the Apple market you have to submit and audit your source code by Apple and so on. And in the Android market you've got lots of different applications. So it's still a work in progress. Obviously you don't want to have dangerous application or software just streams what is going to happen in your house to the website without you knowing. So it's, again, a work in progress.
So I'm still with the 25 DOF and the humanoid behavior, the humanoid movements. If I would scramble my Rubik's Cube, would now be able to handle it? I mean, mechanically, not a strategy.
The hands are not that advanced, actually. So it's just a mechanical device, so you can just close and open them. But my other answer is, why don't you try it now?
Okay, thank you.
Hello.
Yeah.
On the left. I have a question. Do you have any plans of releasing the hardware as open hardware?
Not right now. No, that's all.
Okay.
Sorry. Yeah, okay. So thank you for your time, and thanks.